I'm going to be explaining problem 1 from the 2016 AP test. This is what it's going to look like at the end. So the problem says water is pumped into a tank at a rate modeled by W of t liters per hour for 0 less than or equal to t less than or equal to 8, where t is measured in hours. Water is removed from the tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing on 0 less than or equal to t less than or equal to 8. Selected values of R of t are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. For part A, it says estimate R prime of 2, show the work that leads to your answer, indicate units of measure. So to find R prime, you have to find the average between 1 and 3. And since this table is given in R of t, to find R of prime, that's why you have to use the points minus subtracting each other divided by the time subtracted by each other. So that would be for 3. There's 950 liters per hour minus 1,190 liters per hour divided by the hours, which is 3 minus 1. And this will equal to negative 240 divided by 2. If you simplify that, you get negative 120 liters per hour squared. And you get hours squared since you're dividing the two, which would be liters over hour. That's the top part, divided by the bottom part, which is hour. So when you simplify that, you get liter over hour squared. And that's how you get the units. So then the answer to part A is negative 120 liters per hour squared. And that is what R prime of 2 is. So now for part B, it says use the left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? And give a reason. So here's the table. To do a left Riemann sum, you would use the points 0, 1, 3, and 6. You wouldn't use 8 since it would be on the right side. And you can also draw a graph to know which points to use. So 0, 1, 3, 6, and 8, and as you can see, 8 is on the right side and not the left side. So use all these points on the left. So to do the left Riemann sum, you do 1,340, which is the point for 0, times the width. So that would be 1 minus 0, that is times 1, plus next point, which is 1,190 times the width, which is 3 minus 1, which is 2, so times 2, plus the next point, which is 950 times the width, which is 6 minus 3, which is 3, plus 740, which is the next point, times the width of 8 minus 6, so times 2. And then you add these all up. And when you add all of these up, they would equal 8,050 liters of water. Removed in 8 hours. And now I have to see if this is an overestimate or an underestimate. And since R is decreasing, the bars that we make are over the line. So this is an overestimate. Also, this is a concave up, which is also how we know this is an overestimate. And the reason would just be R is decreasing. So for part C, it says use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So to do that, you would use the equation provided at the top, which is liters per hour, and this is water pumped into the tank. But this equation shows the rate, and we only want liters, so we would have to take the integral of W of t. And since it's at the end of 8 hours, to take the integral be from 0 to 8, W of t, which is 2,000 times e to the power of negative t squared divided by 20 dt. And then it says at the top, there is, and at time t equals 0, there is an initial of 50,000 liters. So we must add 50,000 at the end of our integral, since that's the initial. So you just want to plug this part into the calculator. And when you do that, since you are allowed to use a graphing calculator for this problem, so when you do that, you get 7,836.195 plus the initial 50,000. And when you add these two together, you get 57,836.195 liters. And in part C, it says use your answer from part B. And this is because this will give you the answer for the water pumped into. And the answer from part B is the amount of water removed. So you take this 57,836.195 liters minus the answer from part B, which is 8,050 liters. And this is pumped in, and this is removed. And when you subtract that, you get 49,786.195 liters total at the end of 8 hours. And since it says round to the nearest liter, so you just ignore the decimal points, and the answer would just be 49,786. And now I'm going to show you the part for when I say use the integral. You can put it into your calculator. So you go to math 9, and that will give you the integral. So you put 0 to 8. Put in the equation, which is 2,000 times e to the power of negative x squared divided by 20 dx. See, that's how you get the 7,836 plus the initial of 50,000. That is how you get the 57,000. And now for part D, it says for 0 less than or equal to t less than or equal to 8, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? And explain. So it's basically asking if there's an intersection between the two equations, because when it intersects, that means they're equal. So you would use R of t and W of t. So first you would want to find the beginning points and the end points. So the beginning point R of t is given in the table. It is 1,340. And to find the point for W of t, you would just plug this equation to your calculator and check by the table, and you would get 2,000. So now you want to subtract these two beginning points, and you would get 660. And this is a positive number. So now you want to find the endpoints. So for R of t, once again you use the table, the endpoint is 8. Value would be 700. And then you do the same for W of t. And once again you would plug the equation to your calculator and see on the graph at 8 what the point is. And that would be 81.52. So you subtract these two, and you would get negative 618.48. And you would see that one number is positive and one number is negative. So you know there will be a time where they're the same. Since to go from positive to negative, that means it crosses. So now you need to explain. So you can use the intermediate value theorem to explain. You would need to write W of t minus R of t equals to 0. And there will be a time when the rates are the same. And then based off the beginning point, you can say W of 0 minus R of 0 is it's greater than 0. And for the endpoint, W of 8 minus R of 8 is less than 0. And these two you can explain by the intermediate value theorem. And with this theorem, it says at least one time t will equal. So now I'm going to show you how to get the points for W of t in part D with your graphing calculator. So you want to go to y equals and plug in your equation, which I've already done. And then you want to go to second window. That takes you to table setup. You want to make sure that these two are already on auto, so you already have the points. Then second graph to go to the table. And then to find the beginning point for W of t, you see here at 0, it shows you the value is 2,000. And for the endpoint, you want to go to 8, and you see that is how I got the 81 0.52 value. And now that we've completed the problem, I'm going to show you how this is graded. I have the answer key right here. So for part A, it says you get 1 point for the estimate, and the estimate is right there, negative 120, and you get 1 point for that. And then you get a second point for providing the units, so you need to make sure you have liters per hour squared. For part B, you get 1 point for showing the work for the left Raymond sum, which is right here. So you need to make sure you have that to get 1 point. And then you get another point for providing the estimate, which is the 8,050. And then you get 1 more point for stating if it's an overestimate or underestimate with the reason. So here's the reason with the overestimate, you get another point. Then for C, you get 1 point for using the integral. So you make sure you integral W of t, you get 1 point. And then you get a second point for providing the estimate, which is the 49,000. And then for part D, there will be 2 points. You get 1 point for considering W of t minus R of t, which I've written here. And that is from subtracting the beginning point, the end point. You make sure you write that. Then you would get a second point for the answer with an explanation. And the answer is that there will be a time which the rates are the same, so that's the answer. And then the explanation will be the intermediate value theorem, and then showing this work. And you get 1 point there. So in total, there are 9 points for A, 2 points. For B, it's a total of 3 points. C, 2 points, and D, 2 points. So that is a total of 9. And that is how this FRQ is graded.